laughing all week long.
Well, coming at you live tonight from the Hill household here, we have the topic of the ambiguous case. Now, this is by far one of our toughest topics, so stay with me tonight. It's a lot of calculator work. So if you think back to your geometry days, you had these things called geometric proofs. Now, don't get scared. We're not actually going to do any proofs, but we do need to talk about the reasoning you used. So hopefully you'll remember you could use SAS, which was side, angle, side, ASA, which was angle, side, angle, AAS, which was angle, angle, side, or side, 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 or HL for hypotenuse leg if you had a right triangle. But the most important thing is sitting right here. You talked about you could not use, and we'll write it nicely, SSA. Obviously, if you reverse that, you get ASS. And the polite way to call it is the donkey theorem. I think you can figure out why. I don't know if your teacher called it that or not. But here's the deal. You have the ambiguous case if you have the ASS, the angle, side, side. That's what I'm trying to say. So, the law of sines has a problem, though, when you deal with angle, side, side. So please take, note and copy this down. Basically, what's going to happen is you can either get 1, 2, or no solutions possible. Okay, 1, 2, or no solutions. So again, let's review some quick geometry facts. Number 1, and please write these down. In a triangle, the sum of the interior angles is 180. Okay, so this angle plus this angle plus this angle all have to add up to 180. No triangles can have two obtuse angles. And obtuse, of course, means greater than 90 degrees. The sine function is going to range from -1 to 1. And if sine theta equals positive decimal less than 1, it can lie in the first or second quadrant. And that's huge. And let me just rephrase that. Sine, if I do all students tip cows, sine is positive in the first and second. And that's a huge deal in this ambiguous case. And you'll see that as I go through some problems. So here's the main question they're going to ask. And put this in bold letters and let's attack some problems here. How many distinct triangles can be made? And like I said, you don't have a lot of answers. You're either going to get 1, 2, or none. So if this is multiple choice, whatever the fourth option is, cross it off immediately. You can either have 1, 2, or none. So let's go ahead and attack our first problem. All right, example 1, triangle ABC. Now notice they don't say it's a right triangle, so we're going to draw any random triangle, ABC. We'll label our sides. A is 20. C is 16, angle A is 30, and the question is how many distinct triangles can be made. So I just want to recall our answers. Your answers are either going to be 0, 1, or 2. You've got 3 options. So every one of these is law of sines. So I just want to be clear, we're going to go side, angle across, side, angle across is C. So that's where my X is going. I've got to be finding the side and the angle across. So let's set up our law of sines. I'm going to say the sine of 30, and the angle across from 30 is, the side across from 30 is 20, equals, let's say the sine of X, and the side across from X is 16. Okay, so just like we did yesterday, we're just setting up that quick law of sines. We'll cross multiply, so I'm going to get 16 sine of 30 equals 20 sine X. And I want to solve for the sine of X, divide both sides by 20. So exact same thing we did yesterday, hopefully nothing mind-blowing at the moment. And I'm going to get sine X equals, I've got 0.4. And to solve for X, remember take the inverse. So in my calculator, I'm doing inverse sine of 0.4. And you're going to round this to the nearest degree. I get 24 degrees. Okay, so nearest degree, we'll make a note. They're not going to tell you that, so let's just always round to the nearest degree. Now, that was exactly what we did yesterday. Here comes the fancy part. Here's how you determine how many triangles you can make. All right, you're always going to attempt to make triangle 1. And basically, you're going to list out the 3 possible angles you can have. Now, triangle 1 has to include the given angle, which is 30 degrees. That's not an option. All right, so you have to include 30 degrees. And underneath, let's just write given. We know that's the given angle. And now you just found an angle of 24 degrees. Okay, and that's the one you just found. Now you ask yourself, if I know 2 angles in my triangle are 30 and 24, is it possible to come up with a third angle to make a triangle? Well, basically, these 2 numbers, when you add them together, just have to be less than 180, because altogether, this one plus this one plus this one have to make 180. So is it possible? Well, 30 plus 24 is 54, and 54 is certainly less than 180, so I would say yes, that's possible. And I can in fact find this triangle, or this angle. I'm just going to say that's 180 minus 54, and I get an angle of 126. Okay, so it's possible. We made 1 triangle. Now, since you've got 1, let's get a little greedy. Let's try to make 2 triangles. Okay, so here's the deal. You have to use the given angle. That can't change. That was given in the problem. So here's what we do, and it's all about this angle here. In order to determine what this angle is, ask yourself, I just use law of sines, and sines are positive. If I do all students tip cows, sine is positive in the first and the second. Okay, well this 24 was in the first quadrant. So you basically took care of the triangle that you could make in the first quadrant. Now you have to get the angle in the second quadrant. So basically you're going to take 180 minus your reference angle of 24, and that should get you 156. And you ask yourself, is it possible to create a triangle if one angle's 30 and one angle's 156? Well, together they make an angle of 186. And that's bigger than 180 degrees, which a triangle has, so it's not possible. So in this particular problem, we can say we can only create 1 triangle. Okay, we can only create 1 triangle. Now, if you didn't exactly follow where I got those numbers from, pause it, rewind it, and we'll try another example. Example 2. In triangle ABC, so let's get her set up. ABC. Side A is 7, C is 16, and angle A is 30. How many distinct triangles can be made? So same idea. We're going to go side, angle across, side, angle across. Okay, so set up your law of sines. The sine of 30 over 7 equals the sine of x, that's what we're looking for, over 16. So that's where my x is. Cross multiply. So I've got 16 sine of 30 equals 7 sine of x. Divide your 7 out of the way. I get 1.142, blah, blah, blah. I'm storing that into alpha A equals sine of x. And now I haven't solved for x. To get rid of sine, take the inverse of both sides. So I just want to verify what I did in my calculator. There's that 1.14 number that I had. Okay, I stored it into A, and then I took the inverse sine of A, and I actually got this nasty message on my screen. And basically what that's telling me is if you get an error, that's actually great. Your answer right away is it's not possible. Okay, it's not even possible to create 1. So in this case, how many distinct triangles can you make? Your answer is none. Okay, so if you get an error, you did nothing wrong. If you get a nasty message from the calculator, it's just not possible. So we've got 0. All right, example 3, triangle ABC again. Side A is 10, B is 16, angle A is 30. How many distinct triangles can you make? All right, we're playing the same game. Side, angle across, side, angle across. That's where I'm putting my X. Okay, so I'm going to say the sine of 30, remember the trig function goes with the angle, over the opposite, which is 10, equals the sine of x over its opposite partner, which is 16. Okay, nice cross multiply. 16 sine of 30 equals 10 sine of x. I'm going to divide both sides by 10. Grab your calculator, type that in. I get 0.8. Typically these are pretty nasty numbers, so get used to storing. I'm going to store the 0.8 anyway into alpha a equals sine of x, and I'm going to take the inverse of both sides to solve for x. And when I do that, I get 53.13, so I'm going to round that up to 53 degrees. Alright, so here's the game. You've got to determine, you didn't get an error. Since we didn't get that error, it's possible. I just got to figure out how many I can make. Can I make 1 and get greedy and try to make 2? Okay, so let's set up triangle 1, triangle 2. And I'm just listing out my 3 angles. Now remember, you have to use the given. So if I look back in the beginning, the given angle was 30 degrees here. That's got to be the angle you use right off the bat. Whoops, so I got to start off with 30 degrees. The angle that I just found was 53 degrees. And I ask myself, is it possible to have a triangle with an angle of 30 and with 53? Well, if I add those together, it's smaller than 180, so I know it's possible. So I have one triangle. So I'm going to say basically I can get that third angle. That's 180 minus 83. An angle of 97 degrees. All right, get greedy. Let's try to make a second one. Remember, you have to use the given. So this is still 30. Okay, those should match. Now it's this guy that you're going to change. You did law of sines, so you're positive in the first and second. All students, first and second. This 53 you found is in the first quadrant. Now you've got to put that angle in the second quadrant. So you just do your reference angle, 180 minus 53. And you should get 127. All right, so let's get greedy. Can we make a triangle? If you have 30 degrees and 127, if you add those, are you less than 180? And the answer is yes. So I'm going to take, whoops, where's my pen? 180 minus, if I add those, I get 157. So this third angle would be 23 degrees. So I get 2 triangles. And you can't get any more than 2. All right, so if you get an error, it's none. If you get 1 to work, get greedy and try to make that second one. Now, before I do our last example, I just want to talk about the names of these triangles. So in triangle 1, if you look at your degrees, you have a 30, a 53, and a 97. Because this one angle here is bigger than 90, we're going to call this an obtuse triangle. And hopefully that word from geometry sounds familiar. Obtuse, so maybe make a note. Means you have an angle bigger than 90. If you take a look at your triangle 2, you have a 30, a 127, and a 23. Again, because this angle is bigger than 90, we have a second obtuse triangle. Okay? If, and again, I'm just giving you an example, if you had a triangle that had, let's say, a 90, a 45, and a 45, this would be called a right, because it has a right angle, and since these two are the same, isosceles. And one more quick example. Let's say your triangle was 80, 50, and 50. Notice all 3 angles are less than 90, so this is called an acute triangle, because all 3 are less than 90. And it would also be isosceles because we have 2 equal ones. All right, last question of the night. It's multiple choice, but it's a lot tougher than it looks. You actually have a lot of work to do before you can answer this question. So in triangle ABC, Angle A equals 30, A equals 9, B equals 8. You can't answer this question, this multiple choice question, until you know how many triangles you can make. So notice they didn't even ask that question, but you have to recognize it. How many distinct triangles can you make? And then you can answer this question. So that's an ambiguous case. Let's set up the law of sines. Side, angle across. Side must be finding this angle across. All right, so let's get her set up. Sine of 30 over 9 equals the sine of x over 8. You got this part, come up with the angle, and then we'll compare. All right, so you can follow my work. I've cross-multiplied, I stored my answer into A, took the inverse, and I got x to equal 26 degrees. All right, so let's get our triangle set up. I'm going to try to make one triangle. Now, I didn't get the error right away, so it's probably possible. And remember, you start with your given angle. Our given angle was 30 degrees. I just got an angle of 26 degrees. Is it possible to make a triangle? Well, if you add those two up, you get 56, and that's clearly less than 180. That gives me an angle of 124. So it's possible to make one. And now let's just write down the name of it. Is this acute, obtuse, or right? And hopefully this angle here gives it away. If one angle is bigger than 90, like we just said previously, this is an obtuse triangle. Now you can't answer the question yet until you know if you can create a second triangle. So here's where we get greedy. Let's go for triangle 2. You got to keep that given angle, which is 30. All right. 26, this is the one you care about. We did law of sines, which is positive in the first and second. 26 is in the first quadrant. You need to get an answer in the second quadrant. So all you do is 180 minus 26. I get 154. Is it possible to make this triangle? Well, if you add those together, you get 184, which is bigger than a triangle, 180 degrees. So it's not possible. So I can only create one triangle with one obtuse angle. So if I just quickly scroll back, I'm going to go with one obtuse angle, option 3 here. Option 3. Well, that does it. Take your time. It's not an easy topic, but we look forward to answering any questions in class tomorrow.